Have you ever needed to analyze relations between your customers, or perhaps between your suppliers, or maybe between products and your customers and your suppliers? If that's so, I may have an interesting scenario for you. A client of mine came to me a couple months ago and asked me if I can help to optimize their recommendation engines. Their problem was the following. They were offering certain products to people. But the problem was if there were two people living in the same household, what to do? Some products are not suitable to offer into shared households. For example, if you buy a bicycle, probably you don't expect that your wife will buy a bicycle as well because probably she already has one. Or actually maybe you may be interested in the opposite relations. You may be interested into affirmative. So for example, one of your clients buy a bicycle. So we want to offer them certain maintenance suites, or you can even offer this maintenance suite to their wife so they can buy them and make them happy as a present or something like that. But it's a very common challenge if you have eShop and you really want to know relations between your customers. So how I proceed? Technically speaking, all that you need to do is to create a graph. A graph is a mathematical concept. Don't be scared, it's really simple. It's composed of nodes and edges. So nodes in this case are people. That can also be something like tangible, like products or suppliers for other scenarios. But in this case we are talking about concrete people, customers. And they have certain properties. For example, in this case, you would be interested to know details about client ID for the further purposes, technical purposes, but mainly you would be interested in surnames and addresses. So you create nodes for each customer. And then what you need to do is to create edges, which are representing relations. Relation between customers in this case, but that can be any sort of relations. In this case, the edge represented whether a person is related to certain other person, whether they share a household in this case. So the algorithm that determined edges was just running through all the options, and if people lived on the same address and also shared part of their surnames or the whole surname, then there was a higher chance that they are related and they live in the same household. It doesn't work in 100% of cases, obviously. Some people don't share their surnames, or sometimes people share surnames but they live in some huge block of flat, so then it doesn't work correctly. But in 90% of cases, say, it works very fine, yeah. No question about that. And certainly it's sufficient for optimization of recommendation engine. So the next step was to determine which products are suitable and are not suitable for shared households. As we discussed before, for example, things like bicycles, you are probably not interested to share them inside household or cars or things like this. So obviously, in this case, in your product, you need to somehow indicate that this is not for shared households. In other cases, the opposite, depending on your concrete scenario. So once you do that, it's not difficult to optimize your recommendation engine. Your recommendation engine, if it is supposed to work effectively, already uses graphs. Effectively, it works in a way that you have certain products that have relation to other products and also relations to customers. For example, you buy a bicycle, then it's logical that there is certain relations between product related to maintenance set. This maintenance set, like I don't know, WD-40, you buy a bicycle, you may be interested in WD-40. Also, there can be like relations in time. You buy a certain product, you may be interested to buy it again after a certain period. For example, something for shaving, you buy them repeatedly. These relations are very important and they are in the core of the recommendation engines. So in this case, relation was product had a flag, whether yes or no for shared household, and then we had that relations that determined whether that household people are related or not. So this was the end of story, but obviously there are many other use cases. As I said, for example, between your suppliers, you, for example, can be interested in knowing whether they have a shared holders, and then you need to treat them slightly differently. You may be interested in many things related to optimization of your supply chain, what's like relation between companies in your supply chain, and so on. So there are many use cases for graphs and graph databases. Just to say, graph databases are really modern tools that can help you, technically speaking, to optimize your queries. In this case, I decided to use something called Neo4j, sorry, which is a very modern solution that offers to optimize queries like that and run them in a real time on your system, so that recommendation engine really works effectively, and it's a really computationally effective solution. But as I said before, you can model any type of relations and you can use it very effectively based on your databases that you already have. Perhaps you would be interested in sharing your stories. What relation have you ever modeled between what entities? Was it the customers? Was it suppliers? Was it products? We would be really curious to know. So don't forget to share your stories in the chat below this video. This is all for today. Thank you for your time and please don't forget to subscribe. See you next time.